We are talking about analyzing graphs of polynomial functions and finding turning points, local maximums and minimums. Local maximum, the y-coordinate of the turning point of a function if the point is higher than all nearby points. So right here we have a local maximum represented by this blue dot, and we can see that the y value here is greater than the y value to the left and greater than the y value to the right. So if we just look at this window of the graph right here, that's why it's called a local max, because it's the maximum at just this section of the graph. It's not a maximum of the entire graph, because we can see that these y values over here are higher than this y value of the blue dot. Local minimum is kind of the same thing, but we're talking about the minimum, the y-coordinate of the turning point of a function if the point is lower than all nearby points. So if we look at this point right here on the graph, the y value here is lower than these points over here. So the points to the left and the points to the right, this is the lowest point of this portion of the graph, not of this portion over here. So we can also talk about the function increasing and decreasing and increasing. So we always read a graph from left to right. So as the x value increases from left to right, what would the graph do if we trace it? So we're tracing up, 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 and we get to the maximum. So it's been increasing up until this point, the local max, where the slope here is 0. And then right away, it starts to decrease. The slope is decreasing all the way down until we get to the local minimum. At the local minimum, the slope is 0. And then the graph starts to increase again. And then it's going to increase all the way to positive infinity in the x value. We're talking about the turning points. The graph of every polynomial function of n has at most n minus 1 turning points. So this graph over here represents a cubic function. And so we know that cubic is third degree. So if we substitute 3 in for n, 3 minus 1 is 2. So there's 2 turning points at the most. So there's 1 turning point, there's 2 turning points. A cubic function will not have more than 2 turning points. It can have less than that, but it definitely cannot have more than that. Another way to kind of think of the local max, we know that Fort Mill is in the Charlotte area. So the tallest building in Fort Mill is not necessarily the tallest building in the area, because if we go to make it all the way into Charlotte, we know that there are some pretty tall buildings there. So here we have some graphs to look at. We can see this is a cubic function, and we have a local maximum here and a local minimum here. There's 3 zeros, so this is degree 3. 3 minus 1 is 2 turning points. There's a turning point there, and there's a turning point there. Then we can look at another function here. This is degree 4. 4 minus 1 is 3. So at most we have 3 turning points. So we have 1, 2, and then there's our third turning point. One thing to talk about here is this is a local minimum, because this is spot right here, this window. This is the lowest value in the area, but is not the lowest value, because we can see that there are some lower values over here. This is a local maximum, because in this area, this is the highest point, but as we can see, there are definitely some higher points over here. Down here at the bottom, this is an absolute minimum. There are no points on this graph that are lower. So when we're talking about even degreed functions, x squared highest degree, x to the 4th highest degree, those are going to have either a local maximum or a local minimum, depending on if the graph opens up or down.